Alright, so for this question, they want the total surface area. Okay, if you are still very blur about what surface area means, it literally means the whole area that you can touch of that figure. You can touch, you can't touch inside if it's solid, but the outside, you can touch everywhere of it. In fact, you can even lift it up and touch below. Okay, so total surface area. This actually is made up of two things. One is the sides here, the curved side, like the curved side of a bottle or that milk tea that you're holding on to, and the top and bottom. Okay? So it's a combination of three things again. I say again, one, there's the top, two is the curved surface area, three is the bottom. So which one is the easiest to find first? Top and bottom, because the shapes are? What shape is it when I look from on top? Circles. Basically, it's two circles, the top and bottom. Okay, for 1 and 3. Okay, that's the point. So, you can tell me pi r square already, right? So, pi r square times 2. Because two circles. So, what is the radius of this circle? 6 square times 2. Now, help me out here. Give me a estimation of this value here. Okay, so to 5 SF, what is this again, Shakir? 226. 19, okay, so that's fine. cm squared. Okay? So now the challenging part is actually the curved surface area. So do you still remember, I'm pretty sure the teacher has shown you this before. He or she might have told you the formula, but he would have shown you actually it is a nice shape that you know the area of, or the formula of.
Rectangle.
John says rectangle. Do you agree or not? Yeah. He's saying that the curved surface area, this number part 2 here, is a rectangle. Do you agree or not? Yeah. So, this is, as mentioned, is a rectangle of length times breadth. Okay, so length is actually the circumference of the circle times the breadth, which is the height here. Okay? So now, basically, total surface area, I'm lazy, I'll put SA, is simply circumference of circle. 2 times pi times r of that 6, which is radius 6, times height of 5. Okay? Plus the 226.19 that we just talked about. Okay, so someone help me out here. What's the final answer? 41.690. Okay, so final answer we should give 3 SF, which is 415 cm square, and we are done. So key thing, you have to be very careful with surface area. This is not one of a direct formula that's written on the front page. Front page actually got some formulas there, if you didn't realize. Okay, it is not one of the formulas. You had to break down the parts. Okay, that's really a thing. A lot of you think that it's only one formula straight away can get. It might not be the case. Sometimes you just break it down into simpler parts. So 2 circles and 1 rectangle. Slowly find lah. Okay? So we want to find total surface area. Is this something given in the front cover? Yes, please double check. What is it actually? Pi r
square plus pi r square.
Huh?
Pi r plus pi r square.
Okay. Have you ever wondered why sometimes, I don't know if you ever wondered, why is it sometimes only pi r l and sometimes must add pi r square? Or you don't know what I'm talking about? Have you ever encountered the situation? When I ask you total surface area, then sometimes it's just pi rl. Crickets. So actually, this is okay with you, no issues. Okay, the pi rl is for the party hat top lah. I mean, if you turn it around, it's like a party hat, right? So the pi r square is for the circle on top. Why you need 2 here is because actually of this keyword here that I'm going to highlight here. What is it called? Solid. if it's not solid, if it's hollow, will I calculate the circle on top or not?
No.
Yeah, that's what I'm trying to say lah. I say again, because it's a solid cone, guys. Means down here I can hit it. There is a circle that I can touch. If it was hollow like a party hat, put on top, right? Would I need to calculate that circle on top? Actually don't need. It's simply just down here only. Okay? So let's calculate lah. This one should be pretty simple. Pi 7 and what's the L? 12. Simple, easy. Pi r squared. Okay, this should be simple. What's the answer?
417.831.
How many SF?
3, so 418.
Yeah, find the answer already, so don't need so many significant figure. That's it lah. Okay? So I guess the learning point, the only thing that can be hard from here is that if it's not a solid, then you have to be careful. Actually, this circle don't need to care. Don't need pi r square lah, basically. Yeah? Alright, so for this question, it's an odd shape, but it's a class of a prism. Okay? Prism doesn't mean one kind of shape only. It actually can mean many of these shapes that some examples I've drawn here. So from what I've drawn here, what is a common characteristic among all of them?
Got base and height.
Got base and height. Base of what? Okay, for example, this one over here. What is the base here? This one. There's a base, and there's a height, that what John said. Okay, how about the second one, the triangle? What is the base? Sorry about that. So the triangle is the base, and then you also again have a height. The last one is something like a square, right? With a height. So the key characteristic is that actually all of them have a cross-sectional area that is the same throughout. For example, this one, I see a square all the way. If I were to take it's like a cake, I take a knife and cut, all the same manner, all be square shape. Same here, all triangle shape, down here all circles. How about this little fella over here? What shape is this? Very good, some of you can tell me already. Now what is the property of a trapezium? This is very important because I've seen a lot of papers, they always ask you, make use of a idea of a trapezium. Say again, sorry. What's the property of a trapezium? How to identify first?
One line is straight.
One line. I see four straight lines.
The height is straight, 90 degrees.
The height is straight. Okay. A lot of you are giving me different definitions, but there's only one that's correct.
Got 90 degrees.
Let me ask you, like what John is saying, must a trapezium have a 90-degree corner or not?
No.
Yeah.
No.
Actually,
Yeah,
this is a trapezium as well.
Oh, okay, never mind.
Okay, ready? Understand? So what is the correct definition then?
two parallel lines present.
Yes, you must see a pair of parallel lines. That is the definition of a trapezium. And what is the area of trapezium, everyone?
Half A plus B.
Half
A plus B times
A plus B.
times H.
Okay, and be very clear, which I'm going to write here. A and B refer to the sum of the parallel sides, A and B. And where's the height?
8.
Oh, okay, in this diagram is 8 but basically it's actually the distance between A and B. Perpendicular, yes. Okay, so we're given all this and they already give you the total volume already. Okay, so you just have to be clear on one simple thing. If I had all the dimensions of the area of trapezium, this trapezium, right? And if I know the volume of this, same as this, all squares, all triangles, all circles. If I knew area of trapezium times what?
P.
Times P, By right, if I had all values, it should give me the total of 672. You had to know you got to write this out. Otherwise, you're not going to get the answer, or you won't know what you're looking for. So, to find P, basically, and now I'm just putting the values of A and B. 5 plus 9. Height, I also know 8, which some of you told me, times P equals to 672. Hence, what is P?
672 over the.
Yeah, 672 over the whole bunch of ugly stuff that you see down right here.
56.
Okay? Which is 56, is it?
Yeah. I mean the bracket was not the answer.
Right, thanks. And the answer is 12. Thank you. Okay, I say again, in this question, it's a mensuration question. We are finding total area, but now we are dealing with two types of shapes. One is the one in the center, right? Which is called a rectangle. Now the ones at the sides, what are these called?
Cone.
Hey, it's actually written in the question there. What is it called?
What? Oh, two sectors.
Sectors. Means it is actually from the chapter arc length area of sector. Okay? So in other words, to find the total area, we have to know the area of a sector. So now, what is the clue to tell me which formula should I use for this?
No? Yeah, theta over 360.
Because the angle is given in? The angle is given in? Degrees, 70 degrees. That's why you know it's the theta over 360 times pi r squared. And not half r squared theta. That's for radian. Okay, so the total area of this is actually again broken down into two parts. First part, the rectangle in the center. Second part is actually the two sectors here lah. Okay, so I repeat again, area of sector is basically theta over 360, right? Times what? Because the whole area of the circle, this sector is a part of the circle. That's the point. Times pi r squared pi 10 squared. And I have two of these. Right? And then I add the rectangle of 22 times 10. Yeah? Okay? So we add it up and then let the calculator do the hard work lah. And so what's the answer? 342.17, but this is final answer already, right? So? You know that's all recorded, right? Alright, so the volume of this prism has a base area of a triangle here that you can see. So the volume is basically half times base times height, half times 3 times 4 times the height of 8. So if I use mental calculation, 2, 6, 48, yes. 48 centimeter cube for part A. Now that's, I guess, simple because we just went through prism, the concept prism. Now write down the length of AC. AC, if I were to look at the diagram with my eyes down here, if imagine 3D, is basically a right angle triangle. 3, 4, and now I want this. So yes, the very most basic thing about right angle triangle is Pythagoras. So AC square is basically 3 square plus 4 square, hence AC is 5 cm. Yes, you got to square root the sum of the squares. Now the last one is when we take things from a three-dimensional perspective. Actually, it's exactly what Shafrina just asked me. If I were to look at it from the top here, everyone. Okay, let me see if I can find an idea of a triangle prism. Anything here that looks like a triangle prism? Actually, your textbook is a triangle prism if I have this. It's okay. So guys, this is the triangular prism. Do you see this? Something like that lah. Okay. So now if I were to look at the arrow from where it is, basically I'm looking at it straight on like this. And hence you will see a clear what shape? Rectangle, right? And hence the corner must be 90 degrees lah. Yes. Okay? Therefore the answer is pretty straightforward. Because now if I look at it from that angle, C is here, A is here, F is here, AC is 5 from just now, and we have an 8 here. Okay, we fill in the blanks. So therefore AF must be, again, Pythagoras theorem, pi square plus 8 square, and hence AF must be
9.43.
okay, rounded off to the 3 significant figure. Okay, done. Okay, so find the area of this trapezium, and this is actually a prism, okay? Area of trapezium, half A plus B, so 12 plus 8 times height 16. Okay? So basically, someone give me an answer. 160. Alright, next, volume of it, basically just times the height of 8, or rather the depth, we call it. So 160 times 8 gives us
1280.
1280. Recorded, Right, okay, so 1280 volume. That should be okay. Next. Now, the boxes are packed into a large carton in the shape of a cuboid. Any idea what a cuboid is, guys? What's a cuboid?
It's
A long cube.
a shape. It's a 3D cube.
It's a
Okay, if it's a cube, it will be a cube, means really squares everywhere. But a cuboid actually can be rectangular, like it's like a rectangular block. That's what a cuboid really is. Okay? So the volume of the carton is 0.234 meter cube. So how do we convert this to cm cube first?
Times 100 times
Square root 3 This square root.
100 cube.
Square root 3 lah.
no lah.
How do we convert the volume to cm cube?
Divide by 10.
This is the way to deal with this. First of all, you ask yourself 1 cm, or rather 1 meter
2.4.
to cm.
100
What's the conversion?
100.
100. So if it's 1 meter cube, it actually means 1 meter times 1 meter times 1 meter. Hence, how many cm do I have here actually? It's actually 100 times 100 times 100. You get the idea? So you can slowly work it out actually. Hence, 1, 2, 3, 4, 5, 6 cm cube. Okay? So now if I want to convert this, basically it's times
Like 100.
1, 2, 3, 4, 5, 6 zeros, which is actually a million.
So 1 million.
Your head 1 million.
You tell me what's the answer lah.
2, 3, 4, 0, 0, 0.
300.
No, it's not 2 million. It's 234,000, right? Centimeter cube.
6 0 right?
234,000.
Yeah. Alright, so continuing, the base of the carton is a square of side 60 cm. So basically it looks something like this, maybe. Square of side 60, find the height of the carton. So basically, like for me, equation lah, we already have the area, right? Or volume, right? So basically, base area 60 square times height should give me 234,000. Hence, what is H? Exactly? Okay. That's it lah.